Well, just in time for Christmas, the programmer of Minsky, Russell Standish, has released a brand new version with quite a few substantial changes in the background, and a lot of it changes into the user interface as well. So I want to give a quick overview and a few little videos of the program and how it works. And I'm going to start straight from having to download and install it from SourceForge. So if you start your copy of your browser, I'll use Chrome here, and go to sourceforge.net/projects/Minsky, you'll get this window. And you can, if you click on this button, you download the latest Windows version. I'll just go somewhere else though and show you that there are other versions as well. If you click on Browse All Files, you'll see you can get the source code, because this Minsky is an open source project. You can get Mac binaries and the Windows binaries, and we're going to go for the Windows binary. But if I just go for the latest version here, as you can see, click on that, it'll download. And I get all sorts of complaints about using SourceForge rather than GitHub, but Russell sticks with SourceForge. He's the programmer, so I just stick with SourceForge. There is a GitHub installation as well for those who want to download from GitHub, and there's also a lot of our example files are stored on GitHub as well. So you can see, let's get this little highlighter working properly. Down the bottom here, going through the download and install, I might well jump over this bit of the video to save a bit of time. So once the program is downloaded, you can just click and run. Now when you do, because this is not a registered program with Microsoft, and probably also with Apple, well, it jumped right past what I wanted to show, and that is you'll get a little warning window saying, warning, unknown program, do you wish to install this or not? And it actually says it'll block you from having to do the install, and what you'll see is a little entry saying more info. If you click on more info, one of the options there is run anyway, so do that. You'll get to the point I've got to here. Off we go with the install. And that's done. Now, unfortunately, I couldn't show the Windows hand-holding stage there, but you know, the nanny state of Microsoft will say we're blocked in install. Just look for the more info, click on more info, and that will have the option to run anyway, which will get you to the point I just got to there. So that's Minsky installed. Now, when you run Minsky, you'll get an interface that looks like this, and this is completely foreign to most economists, but it's quite common to engineers. Engineers would be very familiar with an interface like this, and some people working in management and marketing do as well, because the dominant program in the management space is a program called VenSim. And a lot of people ask me, why didn't I add Minsky's features to something like VenSim? I was actually negotiating with the company called VizSim, which is a different program based for engineering use, and it's actually my favorite of the existing programs. But I was advised by by INET, who were the first funders of Minsky, to first do two things: make it open source and produce a compilable version. So that's what we did. Now, one reason I would not use VenSim is visible on the screen right now. This is a model which I'll build when I go through one of the later example files. It's a predator-prey simulation, and what you can see is that there's a prey population that rises and falls out of phase with the predator population that also rises and falls, and if you plot the two against each other, you get a closed cycle. And let's simulate this model. Click Simulate, click Run, bang. What happened? Well, you're seeing it after the simulations have been run, and you see actually going on. You've got to dive inside the boxes to see what the definition's here. So what's the definition of prey population? Right click. Now the first option you get is to change the font. Well, whoopee-doo. Why on earth the font first? I'm interested in the equation. Click on the equation window, and you then say the equation is over here, prey births minus prey deaths. I'll zoom in there a bit just so it's more visible. Prey births minus prey deaths with an initial value of 100. These are the variables feeding into it. These are the functions you can handle, add to make your definitions and so on. I'll cancel out of that. I find that an incredibly cumbersome interface. So design, to me, starts with the wrong thing. Why make the font the first thing you change? Secondly, you can see that the fonts you have for obviously all English language, all the text. So if you look at the variables here, prey death proportionality constant, what's that? Well, again, bang, let's change the font first. click on here, here's the equation. Oh, it's 0.02. Get out of there. And what's the pre-birth fraction? Right click on that equation. It's 2. Okay. All right. But getting an overview of the whole thing is quite complicated. You can't see it running dynamically, and I've never been a fan of the VenSim interface. So let's just shut that down and see what Minsky's differences are. So here's Minsky. So what Minsky does is basically make all the equations graphical, and it's not. I know a few economists thought that I'd invented the idea of using wires to connect variables in a model. No, in fact that was invented about 60 years ago by J. Forrester when he was converting a pen and paper model he built, explaining why there are cycles in the output of a particular factory. I mean, it's all about the endogenous time delays in the factory between deciding to produce a new product, designing it, testing, marketing, and then producing, etc., etc. The internal dynamics cause cycles the company couldn't understand, and Forrester then realised this was a framework for displaying dynamic systems that wasn't as intimidating necessarily as doing a set of equations. So the idea was you define equations using flowcharts, and the arrows are used to assign values to different entities. So I'll quickly show what that's like. Just to take you around the interface itself, here's your classic menu. File, edit, insert, options. Runge cutter is a numerical simulation component built into the program. You don't really worry about that. Help isn't the world's best help. I need help to write the documentation because, of course, I need funding to get any of this stuff done. But if you bring it up, you'll get a fairly basic explanation of the previous version of the program, which is it's still relevant to the current version, but it explains the whole idea of how the flowcharts are developed, what you need, the menu, etc., etc. So there is help there, and please, if you do get stuck at some stage, give that a try. But let's just go through the components past that. You'll notice there's no ribbon. There is never going to be a ribbon. I regard the ribbon as a stupid interface designed by Microsoft, and I'm not going to copy it. But you then have a set of buttons here. These are unique to Minsky. These let you record a simulation as you build it and then replay it later. I'll use that in one of the later simulations. This is to run a finished simulation and stop it as well. Run and stop button, the usual sort of story. Run goes to pause. Stop button to go back to 0, and step to increment by 1 step. This will change how fast the simulation occurs, and if you have a large simulation, you want to zoom out and see the whole thing. Click on this one several times. Each time you do, you can't see it right now, but you zoom further out. This zooms in, and this resets to 0. What we have here, we call this the wiring tab. This is a canvas on which you design your equations as a set of flowcharts, and as you do it, Minsky generates equations over here. Those equations, just to go back to the file menu, can be exported for use in programs like sophisticated word processing programs like the LaTeX programs, and also in less sophisticated things like Word. Choose Export Canvas. This is slightly complicated. I want to improve this for a later version. What you get is 4 possible types of outputs. SVG is a form of vector graphics file, so you can actually take a model and then whack that into a document if you're trying to explain how you develop a model. PDF, which is new, you can export the model as PDF. Thanks, Russ, I hadn't noticed that one. PostScript, so going right to the code that is actually used for running your desktop printers. LaTeX, and the LaTeX is a mathematical equation formatting language which people in science and technology use in general, and then MATLAB. So if you wanted to produce a complex model and then document it, you use LaTeX as your output, and you can import LaTeX into Word documents through the program MathType. So those are various ways to get what you produce out of the system, because there's nothing here so far. So let's show the next most important, well, one of the most important parts of the program are these little icons here. And what they let you do is create various entities that you place on the canvas. I'll come back to the one the arrow key is on right now, which is the Minsky, the Godly table for showing financial flows. That's the most important innovation in Minsky. But you can insert a variable, a constant, a parameter, an integral, plus key, minus key, multiply, divide, log, etc., etc., a whole range of mathematical operators. And then over here, finally, a switch, which is this one here, a graph, and a comment. So I'll take you through using the basics right now. And the basics of Minsky is it's a way of designing equations as a flowchart. So I'll make the simplest possible equation, a plus b equals c. And let's start to actually create the variable a. I click on the variable button here. I then provide a name. I can give initial value, let's say 10. Now, one thing which is tricky about Minsky is that the cursor's location is determined by the arrow, by where the mouse is. You can see it's moving without me pressing a tab key. I don't particularly like that, but that's a feature that comes from just having a Linux foundation rather than a Windows foundation. But just get used to that. So I've now typed a value of 10 up here, a maximum value of 100, a minimum of 10, and a step size of 1. I'll show you what that means when we bring it up there. Click on OK. You then have the variable a, which is at this stage attached to your cursor. And wherever you click on the canvas, that's where a stays. So I've now put a down on there. You'll notice, by the way, that it's showing 0.00 as its value rather than 10. If I click the Run button, then it becomes what it should be. So that's just a little quirk. We have to fix that particular bug up at a later stage. So that's A typed onto the canvas. I can do the same with B. Let's type, so B, initial value 20, let's say, maximum, say, let's copy the maximum minima from the values I gave for A and A to go. Click OK, place it down here. Now when I add them together, well, I come back up to the cursor, up to the palette here, and I've got a plus operator. And then I can say a plus b equals c. Now I'm going to show you one of the important features of Minsky that no other System Dynamics program has. And this is, again, one reason I designed it. I used to work as a software editor for a couple of Australian computing magazines, and I got to see virtually any program I wanted to see. And I saw lots of good ideas in different programs that I thought would be useful in Minsky. So one of them is, why not type straight onto the canvas? So if I type the letter C, then I get a little dialog box here, and I'll explain why it's a dialog box rather than typing the text straight away. But I'll come back to that. Press the Enter key. I get the same old menu went up here to define it, but I want to make C as the product of A plus B. Just press the Enter key, and I've now placed C on the canvas. So there's my basic beginning. Now, if you go across to the Equation tab, you'll see A and B and C have all been entered as variables in the system, but no equation yet. So to make an equation, notice when I highlight, when I go onto any of these objects, there are, in the case of A plus B, 2 circles, one at the back end, one at the front. In the case of the plus key, there are 3. And the reason for that is these are nodes from which you drag an arrow, and the arrow then connects the 2 variables together. So and I don't have to get it, I'll do it properly here. Take it up to where I know the node is here, release the arrow, and I now have A connected to the plus key. If I do the same to B, I'll release it just shortly away. You see that I'm nowhere near actually the mouse's move. I'll just go back over here. Let's see. Mouse is too sensitive. But I'll drag it over here, let go, and if it's close to another input node, it'll snap there. So let's just try that again. Okay, so it snaps to the input node. And now, actually, I can also magnify this natively in Minsky so you can see more clearly what's going on. If I hold down the Shift key, I can drag the whole canvas so I can recenter. Now you can see the larger circles there. If I click out and release the mouse, bang, it goes to C. And now I've defined the equation, which you'll see over here. Now notice there's nothing there. That's because I have to reset. We haven't actually done much about zooming on the equations here on the Equations tab. That's a further development. So click on the 0 key, and then you can see the equations now stated here, C equals A plus B. Now, let's go back and I'll hold the Shift key down, drag the canvas over and zoom in a bit. Now I want to see that outcome. You can see 10 is assigned to A, B is currently shown as 0, and C is 0. If I click one step on the run, then you can see the maths is now correct. Got 10 for A, 20 for B, and the answer is 30. Well, whoopie-doo, you wouldn't bother doing this for simultaneous equations, but what you can do with Minsky, and this is the very beginning of showing it, is you can graph these things. So I'll put that onto the black input there. If I right-click and choose Resize, and I can make the graph larger, and this is now going to show the value of A plus B over time. Again, this is pretty boring, but you'll see why I'm doing it in the next simulation. So correct set back to 0, and there's the value shown as 30. Now, notice these dots here. What Minsky does is every variable, every parameter has what's called a slider, and that dot there. If I click on the mouse and drag it, then I can change the value. And now you can see me changing the value fairly radically. Not by the step size stated in the program. This is another bug we have to address. So if I right click and choose edit, hang on, pardon, I chose row name by accident. Right click, choose edit. Right, okay, the step size is not being obeyed, so another thing to be fixed up. Another one to show to Russell to get straightened out. That should be the step size is 1. In fact, no, I realise Russell will tell me, using the mouse is different to using the arrow keys. We make it possible to change the variables not just by using a mouse, but also by using the cursor keys. If I highlight B and press the sideways arrow key, I step it up by 1 at a time, as I've defined in that dialog box. And you can see the value of C changing as well. So one advantage you can see straight away compared to VenSim, which I showed a moment ago, is that Minsky's graphs are dynamic. They actually show you the simulation as it runs in time, and time is shown way up in the top corner up here. Okay, 146 time units, which in Minsky the fundamental time unit is years. So that's absolutely basic. You wouldn't use Minsky just to do this, though what you might do is whack sine and cosine in there. So I'll show that quickly. And notice up here we have, amongst the many operators that are here, we have sine and cosine and tan and so on. So let's show what I can do with that. So that's going to click on, that's sine or log? Log, I better not try that, I'll just delete that operator. We make extensive use of the right menu key, by the way. So if I go in here and choose the right menu key, edit, I might change that back to 26 to get rid of the variability brought in by using the slider. And then just stop and click, and it starts on 26. Okay, so let's just get rid of that lot. I'm using a rubber band now to go around the objects, and if I right click in the region I've defined, then I can just cut them, he says. There they go, it takes a while to happen. Okay, let's actually define sine and cosine and show how they interact with each other. I bring a sine down here and a cosine here, and you want to graph the two on that chart, then you attach to the inputs, and notice, by the way, the size is wrong. This is another little bug. The size should be proportional to the level of zooming that I've done. That's not happening at the moment, so another thing to get straightened up. So sine and cosine, tiny as they might be, are sitting there. Now if I try to do anything, nothing is going to happen because sine and cosine need an input. And this is why you'll see there's the circle at the other side, and the obvious input is time, which is up here. So I click on T, I can then drag this here and have sine and cosine coming out, and now when I click and run, I'm going to get the sine and the cosine displayed dynamically, and that makes it a very good teaching tool for mathematicians. I'm aware that a number of mathematicians around the world are using Minsky to demonstrate various mathematical operators and how they interact with each other, because there are very few other programs that actually graph these things dynamically. And one advantage of that is there's sine and cosine graphed against time, and notice down the side of each chart there are 4 inputs on the left hand side and 4 inputs on the right hand side, and 8 down the bottom, plus on each axis there are 2 angled inputs. The angled inputs let you define a maximum and a minimum for each axis. The coloured inputs give you the coloured charts, as you can see, but if you also, for example, attach, let's say I might attach cosine here to the green, and I'm going to attach sine to the, actually that would know that it's not going to work on time, it's going to be too messy. So if I go to that line that you see when I'm highlighting, a line of blue dot turns up. If I press, whoa, that wasn't what I meant to do. I meant to do that. So let's actually put time back there again. And let's make this chart a bit smaller. let's bring in another chart and resize this. And actually, I might put that over here. It's going to be messy, but I'm going to drag that over to the, let's say, the green input over here. And if I do the same to cosine, to the green input down here, that's looking pretty messy because the wires are getting in the way of the chart. So if I click on up, everything is, what actually gets captured is an issue sometimes. The graph is getting in the way of me trying to capture that line. But what I want to do, okay, you've got to better highlight the blue dot so you can make the lines into curves. They won't look particularly good, but I'll do it here just so they get out of the way of the program. Then you get extra dots as well, as you can see. They let you make the curve more extreme. So this is the one I was working on there. So now I don't get in the way of the chart, and ditto this one up here. So now I've got sine as the input for the vertical axis on the second chart, and cosine as the input for the horizontal. And of course, if you simulate the two, you get a circle. It won't look precisely like a circle because the shape of the graph is not perfect. But this is a nice little teaching tool again. And again, one simple thing Minsky has done, which I haven't seen any other program do, is we simply have a marker at the current time point on the various variables. So you can see we've got up to here. That doesn't matter particularly on a dynamic graph like that because you're seeing it go past anyway, but it does matter on the XY plot to see whereabouts you are, and that's what that little dot is intended to do. So that's stage one. I'll go on to stage two in a short while.